Hey guys, welcome to Tangle Talks. This is your host Shubham Das, and today we have with us Samarth Tehri, and we are going to be discussing something extremely interesting. It ranges from things like self-driving cars goes ahead to your iPhone recognizing objects around you and labeling them as animals, plants, and other kind of advanced technologies. We're going to be talking about computer vision, guys. Welcome, Samarth. How are you?
I'm doing good. How are you?
I'm doing great, Samarth. So, right off the bat, what is computer vision?
Basically, it's a process where it recognizes images and classifies them into different segmented objects, so that the computer can easily recognize what is like a person is walking, or if this image is a different color, or if an object is like an apple or an orange. Basically, that.
All right. So, is it correct for me to say that it's some kind of an artificial intelligence algorithm in which you feed, like, let's say, 10 pictures of an apple, and then the algorithm understands what an apple is generally supposed to looks like. It breaks it down to pixels and stuff like that. And when I show it an apple in real life, it can recognize it. Is that how it works, or can you just give us an
Precisely.
understanding
That's
of?
exactly how it works. It uses a lot of math and a lot of algorithms to process
Okay.
an image. Like, it first basically gets an image and then checks outline, its
Okay.
shape, and because an image has a color, it checks the color, and then it learns all of this. And then when you show a
Hmm.
real image, it'll compare with that image and it'll classify the object.
That's amazing. So another interesting application of this which just hit my mind right now is Snapchat filters and Instagram filters. Is that the same algorithm, or like is that just a product of what the larger computer vision uh, goal is?
It's actually both, but it's more on the product side because in Snapchat, the algorithm every time whenever you use the filter, it actually changes because
Right.
not every person has the same face actually. So
Mhm.
the filter adjusts, and based on your eyes, nose, and mouth position, it automatically calculates where those funny filters will be, like the famous dog filter, like the ears over
Right.
here. It's pretty fun.
So that's interesting. So this algorithm can kind of adjust to different face sizes, different body sizes. So it's basically learning. While that's what machine learning is, right? I mean, it's basically learning on uh, identifying different shapes and sizes of objects.
Yeah, machine learning is a very big field, but computer vision is like that small part of machine learning that's
Right,
extremely math intensive and fun and applicable.
right. So speaking of applications, I think you're an extremely enthusiastic about self-driving cars and the application of machine learning within this. So could you just give us a brief overview of where does computer vision come into self-driving cars?
So basically, that's the entire principle behind why self-driving cars are working and why it's famous for. So,
Mhm.
how does a car self-drive? It uses a lot of cameras around the car. You might
Right,
not notice it because nowadays cameras are small. The cameras are like those fisheye lens, like the GoPro type cameras, where you can record
right.
very large fields. And so, what the computer vision algorithm and the computer in the car does is it just takes those images and videos, stitch them together in one 360-degree full world field, and then it recognizes if a person is walking, or if the street is like going straight, if there's a lane change, or if there's a car going behind. All of them it calculates at the same time, and then
Mhm.
it gives an output to the car. So the car will either drive forward, backwards, left, right, or do a slight turn.
Definitely. I haven't had the opportunity to sit in a Tesla, but I did recently have the opportunity to sit in a high-end luxury Audi, and that had something called a self-parking. So I think self-parking is very common amongst the luxury cars, if not so much like, as popular as something such as self-driving cars, which is not that popular yet. So do you think self-parking also uses these same kind of principles of computer vision to kind of navigate parallel parking and stuff like that?
Yes. In fact, most of the newer cars they also have the parking assist feature, where when you
Right.
turn back, it shows in that small glass, the back glass. It shows like the car lane, and then shows like a virtual lane thing. When you go back, it just turns left or right. So it really helps in assisting. It also
Right.
helps in like when you change the lane, and sometimes you can't see because of the blind spot.
Mhm.
It's a collision avoidance thing.
Cool. So let's actually zoom out for a bit. You, as a computer vision enthusiast, do you think that we are moving towards a world where everything is going to get automated and the human input is slowly tending towards zero? Or do you think the human input would always be necessary? Because I think I read an article recently about Tesla, wherein although it's a self-driving car, you need to still keep your hands on the driving wheel for about a certain, like for some certain durations, because at the end of the day, there are some things which the artificial intelligence isn't intelligent enough to do. So do you think we are actually moving towards human input tends to zero?
Possibly, but not in like 20 years. Definitely not in 20 years. It'll take probably 60 to 80 years, but then new fields of jobs will appear. Like right now, you can see there's no, like, if you go 20 years ago, there's no job called software engineering for iPhone apps, but now there's like pretty much a very big market. So jobs will change. And yes, eventually driving might be fully automated, but you still need to have a hand on wheel.
That's interesting. So another application which we need to discuss today is about surveillance and about security, and I think this plays a huge part. So this is a project which I came across in my college. Like last year, due to the COVID pandemic, many people were not wearing masks in the street. And there was this project which came out which could identify the faces of humans, and in that face, which people are wearing masks and which people aren't. And it could catch out these kind of people who aren't following the protocols. So I think that is like a good starting ground for what surveillance could possibly look like with computer vision. Could you give us a few more examples and insights as to where you see these applications coming up in our real life?
One famous example is that when you go in like an airport and you have to go to immigration, there's already a camera just checking your face scans. I think UAE already has one where you just scan your Emirates ID card, look in the camera, and then it enters you. So that's one where like surveillance can be used.
Right, but where does the computer vision or the AI algorithm come into that? Like, what are they actually tracking within you? Are they connecting you to the database of pictures they have of you, or like what's exactly happening in the background?
So basically, what happens is while your picture is being scanned, it checks for common features between you
Right.
and the photo you provided. And if
Okay.
it's say like it just compares a very high percentage of match. If the match is more than like 99%, it is sure that you are the same person traveling. It's also accurate enough to detect twins. It's that powerful.
Wow, that's really interesting. So that's a great example that you gave us. Do you think that more and more of these surveillance system becoming automated and computerized, do you think this is more of a security risk or a security boon? Because the way I look at it, like assuming if all our security systems do become based on algorithms and based on computer vision, it also becomes susceptible to hacking. So I think what is the trade-off there? Like, what do you think are the safety features of this?
Yeah, it's more of a risk right now because we don't have enough like powerful algorithms to prevent attackers from attacking the systems.
Mhm.
Also, there's like a percentage of bias factor. Like sometimes it also checks records online and checks if you have like not just committed a crime. Like it checks if your group has committed a crime. So because of that feature, or you can say that's a bug, it automatically just assumes you have done a crime. So it's kind of racist in this sense. So that's why human input is still required.
That's an interesting insight that you bring us. So let's go a bit personal now. Let's talk about your journey with computer vision. So when did it start? How experienced are you, and how did it start?
So it basically started in ninth grade. So I was in the robotics team, just doing some competitions. Then we had this problem of sorting blocks with colors, and we were limited with the amount of sensors we had to use, and we cannot use camera in that sense because it was expensive. So what we did is we used the color sensor, and but the problem with the color sensor, it can only detect like the color of the object. It cannot detect the intensity of that object because we had to also separate blocks with the intensities, and then we hacked the color sensor. Because of the distance, the more closer you are, the more intense it is. Hack that and assumed it's a camera for now, and then you can actively like segregate the blocks and put in the correct places and win the competition.
Oh, congrats! That's a great story of how you need to always think out of the box to go ahead in life. That's interesting. So what are the softwares that got you started off with, or like what got you interested in this? Like, how did you build up the skill?
Oh, so basically, of course, Python. It's the even you can start it using Python. You can do it right now. It's a very easy language to learn on.
Hmm.
And the thing is, the computer vision doesn't require a very powerful computer or anything else. It just requires a device which has a camera and can run Python or any programming language. I
Hmm.
think we're just talking one on right now. A computer, any computer right now can do it. So
That's
yes.
amazing. So the requirements are very, very minimal. But what about the time input and the skill? So could you suggest us a few courses or any kind of website where you learned Python, where you learned computer vision?
Oh, so basically, it's a skill that requires a little bit of math because it needs to detect edges in an image. It
Right.
also requires some Python skills or like programming skills. Any programming would work,
Hmm.
and it also requires um, basically what do you call the thing again? Yeah, it also requires the ability to like hack into devices.
That's very interesting. So let's go change the topic a bit. Let's talk about a different field. Let's talk about the medical field. What are the applications of computer vision in medical field, and how can it help save lives?
Oh, so this is a very diverse field also actually. So, for example, uh, in a dermatologist field, the computer vision can detect like what type of skins have allergies or cancer or other medical conditions and actively help the doctor in assisting like, okay, this patient needs this medicine or this is the disease. So it can
Uh-huh.
classify of like diseases instantly. Same goes
Right.
for X-ray because in X-ray the doctor has to check like, what part is broken and the whole thing. While the computer can just go and scan in one go and tell you if the patient has like a fracture or some kind of illness, etc.
Basically, becoming a personal assistant for the doctors to make much more analytical based decisions on their patients. That's I think that's an amazing application. I think that's a very interesting field for people who are in biomedicals or in biotechnology, to further explore on. So I have a personal question for you. How do I start off to make my own self-driving car using computer vision? Or like, what is the first step towards this? Like, can I, is as a small project, is it possible? Because I'm
Yes,
sure
it's
that
very
all of
possible.
our listeners are very interested in, getting to know how to make their own small self-driving car. So could you please tell us what is the blueprint?
Yes. So the blueprint you require is a computer with a camera and the ability to code in it. All you need to do is just download Python, which is freely available. Then there's a library called OpenCV, which is called
Mm-hmm.
Open Computer Vision. It has
Mm-hmm.
tons of algorithms and tutorials available online for free, even on YouTube
Right.
nowadays.
Right.
And because of that, you can just start typing. And it's also easy to understand. It's more like written English than some alien codes.
Mm-hmm.
So you can start with like image recognition, and basically what does it do in Python is it creates a borderline box around your face, so it can
Correct.
detect if a person is there or not. And
Mm-hmm.
with that, you can go deeper down in the levels and
Right.
then check if the person is like young, old, different color of skin. You can tweak the variables and it'll show.
That's amazing. So now that I've downloaded Python, I have also taken up I've learned a bit about computer vision. I know how to, detect objects and probably faces. How do I also? I also need to go ahead and kind of make that into the hardware. So you spoke about sensors. So are you using Arduino, Raspberry Pi, or like what does the hardware side of it look like? What's your input on that from the robotics point of view?
Really depends on the hardware actually. Any hardware could work. Arduino can work, but there are limitations. Like it's just not powerful enough to compute everything. So what
True.
people do nowadays is they just put the hardware and all the simple stuff aside, make the hardware cheap as possible, and then connect with the cloud so that all the processing and every other computer vision application gets processed in the cloud. It's very
Right.
efficient.
Right. It's extremely interesting. So thank you for telling our listeners on how they can, at least get started off on building something really cool, which is going to be a very fun project and also an insightful one. and I really hope that people do take up this blueprint. Uh, all right. So coming on to our next topic, we are now going to talk about something interesting. We just had a chat about this. You told me this very interesting example of how Amazon is coming up with this kind of groceries wherein you can just go in and probably pick up some items, and then your face will be scanned that, okay, let's say Samarth has picked up a bag of Lay's chips, and you will directly be charged through your Amazon Pay account, and you can just take it and walk out, and that makes the whole grocery process extremely seamless. Why do you think this is not breaking out yet? Like, what are the obstacles which are there in this as of now in status quo?
Okay, so the number one obstacle is like, okay, if a person has chosen an item and placed it somewhere else like wrongly, and another person can just take that item from the wrong section, the computer vision is not accurate enough to detect, not pick, like not really precise enough to detect if the person has chosen the right item or not. Second, like those pickpocketers can just come and steal the item from another thing, like looking away from the camera, so the camera can't really detect if somebody has stolen an item or not. So that's one problem.
Okay, that makes sense. So that's one problem. Could you also suggest a solution to that problem from computer vision? So one thing that comes to my mind is uh, any kind of, like, let's say that each of the item rows in and of itself have some kind of like ATMs have cameras monitoring whether you are, like, not
Yeah.
uh, trying to steal or trying to do anything illegal. So what if these rows and shelves of foodstuffs and groceries also had cameras kind of monitoring and having their own surveillance system within there? Do you think that's a possible solution, or could you suggest something more nuanced?
Okay, so that's place where cameras become expensive, because building one camera is not a cheap thing to do. What other people have like suggested is using pressure sensors to detect like the weight of the object and like
Hmm.
the size of it, because pressure can calculate force and area. So
Right.
that could be used for detecting like which type of object is there or what's in the wrong place.
That's very interesting. So that's an application that we spoke about on how it can help our life become much more seamless. We spoke about self-driving cars. We also spoke about how it's used in medicine. So now that we've understood what the future is, I think it's an interesting topic to go back to what the history is. So can you tell us about what the history of computer vision looked like? When do you think it started, and what were the initial projects and what were the hurdles?
Okay, so the initial history actually goes back to 1960s. This is before the internet actually exploded. So basically, it started as a summer project in some university that they think that they could complete in one whole summer. So what the project was to detect, like if a camera can detect any
Hmm.
object, and then it takes an object and just tells the object's color and recognizes it. It was actually much tougher than previously thought of. But then over the years, it became more simplified. Cameras
Hmm.
can now become like, in those times, the cameras were like hardly in kilopixels, not even the megapixels you can find in your phone. So,
Right.
so you're literally looking at pixels. And movies that time were in like black, no, not black and white. It was more like, it was those film reels movie.
Right.
Yeah, all times. But overall, become more diverse. And in fact, I think since 1980s, if you go to a shopping mart, you'll
Hmm.
find those optical scanners where they just
Right.
scan the object. It's much faster than typing the entire object serial number on computer and
True.
buying the thing. So it increases productivity. And then comes 1990, where they started using cameras and, well, CCTV cameras. That's the thing,
Hmm.
in like bank stores, so it prevents robberies, ATM machines, and it just become more refined.
That's amazing. So now we know what the basic history has been. So one thing I can't help but wonder, so as cameras have improved, so has computer vision. Nowadays we have infrared cameras, we have cameras which can detect uh, dark matter, cameras which are like so far advanced, you can go in so deep or go in so far. Like we recently saw the telescope which took the first picture of the black hole, and we have such advanced camera technologies. So do you think computer vision can kind of leverage this, and can you just tell us, like, how could we possibly use cameras which can see in the ultraviolet range or in the infrared range in to like help us out? Like, can it help us stop any kind of radiation, like any area which is so? Where does what else can computer vision do with these new camera technologies that have been developed?
That's a very difficult question to answer because each field, like the aerospace field, has different types of cameras to detect anything else, and then medical field has completely something else to do it. But like for example, I'm going to say for the consumer field, like what you can
Hmm.
do right now is like your phone probably has a camera feature that can like I think it's called Face ID for
Right,
iPhones, and for Samsung it's a face scan. So you can unlock your phone by just looking at it. It
right.
improves speed and efficiency, and like banking. That's two fields that really require computer vision enhancements.
That's very interesting. And one more thing which I just noticed is like I think Huawei came up with this technology. I think a couple of years back, wherein if you point your phone, like a normal camera towards a plant or an animal, it recognizes that this is a plant, or this is a flower, this is a vegetable, this is an animal, and has specific filters for those kind of objects, specific layering, specific kind of lightings for these kind of objects. So that's really uh, also a consumer product as to how we are using this kind of computer vision to make our photography better, make our general social media aesthetic better. So I think that's one more area which the I think modern tech companies are capitalizing on. So Samarth, let's like get back to your story again. What were the difficulties you faced in your journey with computer vision? Like, where did you feel that, oh shit, this is something where I feel that I am stuck, and like how did you overcome that?
So basically, the place I got stuck, it's more of like it's not about math or like programming. It's more about like changing from one platform to another platform because some computers, like for example Windows and Mac, that requires a shift and you have to learn the entire new operating system. That's one small hurdle. And other
Right.
things are like programming language because well, Python is very easy to learn, but some other programming languages have like very high advantage like MATLAB, but it
Mhm.
requires a pain to learn the whole thing. So that's the problem right now. And then comes algorithms. But luckily
Right.
we have a book online and you can just search it up online so you know what
Right.
algorithms are.
That's amazing. And I think that's where Tangled also comes in. I think Tangled is a great peer to peer network wherein, people like you can help out our listeners to kind of overcome their hurdles and, help them out in finding their path into computer vision and help them kind of understand what the nuances are as well as develop these skills. And, just by sharing your journey or at least, you being there as a mentor or as a figure to them, they can always be ensured in the knowledge that there is somebody who can help me out in case I face anything. So I think that's a really great thing that Tangled is doing here. On that note, you spoke about visual bionics and how computer vision can actually help people who have impaired vision to kind of see things. So could you like touch upon that and like expand what you were going with?
This is a very experimental field. So basically the camera sensors can detect objects and get electrical signals. That signals can be reversed, like it can be injected in your brain wirelessly because brain waves, and then your brain will instantly like remember that object was there. So it's more
Wow.
like yeah, you can say it's like a third eye at that point, but it's a very experimental field.
Is this something which Elon Musk is doing with Neuralink?
Yeah, quite so. But he's doing more like for the paralysis people and injured people, but it's quite a field.
Well, that's a interesting question for you. You, as a computer engineering student, imagine you had all the resources, all the facilities, all the finances. What would you think? What new would you like to bring to this field? Like, what is the next big thing that you want to contribute towards? Like, what's your vision?
So micro robotics is one field because computer vision exists now, but to optimize it and make it small enough so that it can like, for example, heal people. That's one thing. It can detect cancer or any other like illness. Other places could be like like something to do with Amazon Go, that online like they can just pick up the shelf and go. and
Right.
improve user productivity. Things like that. It's an
Wow,
experimental
that's
stage.
great. That's a good vision to have, and I think, no pun intended, good vision to have.
I got
Anyways,
that.
so yeah, this is, I think, a great direction to go towards. Helping society become much more optimized at large. Right. Is there anything that you wake up in the morning and like you get the kick, like this is something I want to do, and this is why I want to do it. Like what drives you towards this goal?
Augmented reality. That's one thing that drives me towards the goal. Like, imagine a world where you can like live in the digital society and in the real society at the same time. For example, Zoom classes right now are pretty terrible, but what if you're in an immersed field, like you're in your table and you're actually in the class? You can see left and
Right.
right the students. Same will go for office space and other things.
Right. It's a very interesting thing you brought up because I was recently working with this project in my college, wherein they were like they were working on this technology about a virtual laboratory. So there were two or three products of it. One product was obviously using virtual reality, where you could just uh, put on those glasses and you could explore a science laboratory from anywhere in the world. You could literally pick up things and see how chemical reactions and things work. Another application was something through your phone, like basically how Pokemon Go worked. Basically, you would see a laboratory through your phone in your own room. This is for people who are from marginalized communities who can't afford to go to these kind of high tech laboratories. For them to kind of, you know, be able to at least have basic physics labs, chemistry labs, and things of that sort. So I think that's a very interesting field to develop for holistic education of all these kind of communities. What was it that got you interested in this field? Like, why did you pick this out of all the other things?
Um, Robotics is one thing. Efficiency. I'm just gonna say some few words: robotics, efficiency, and optimization. Immersiveness, like immersion, living in the digital world and real world. Remote connectivity, like for example, you're
Right,
missing your parents, your family, friends on a different
right,
place. Connectiveness and social life.
right. So basically, I think computer vision is taking leaps and bounds in making the world much more globalized, making everybody feel much more connected through augmented reality, through robotics, and through other things which we spoke about in our podcast today. So it was an extremely interesting conversation. I learned a lot, and I'm sure our listeners also learned a lot. We would love to have you on Tangled, where you're going to engage with our listeners more, with our students more. With that, we are going to close the podcast for today. This is Shubham Das signing off. Thank you, Samarth. Have a nice day, guys. Bye bye.